Welcome to Programming Knowledge. Today I'm going to talk about how to control servo. Okay, let's go. Servo is a device is quite similar with the step motor, but it isn't exact as the step motor. Okay, this is the inside of servo. This is the control circuit. It is integrated from H-bridge. The H-bridge is the circuit we usually use to control the motor. That's just a circuit help you open and close the control signal from the microcontroller. Okay, the servo, to control the servo, we will use the PWM to control this circuit, to control the control circuit. And the control circuit will control the DC motor and potentiometer at the same time to operate the gearbox. Okay, the potentiometer will affect to the angle and the DC motor will affect to the speed, and the gearbox can up to 60 RPM. There are many types of servo, but I have some popular servo like this. The first is blue servo. This is the cheapest servo and the quality is quite good. It can pull about 1.8 kg when we supply it 4.8 voltage, and it can be pulled 2 kg when we supply it 6 voltage. And this just approximate. Maybe it can pull 1.5 or higher, okay, because it's just approximate. The blue servo can rotate from -90 to 90. That's 180 degrees when you plus it each other. And the next is black servo. It's more expensive a little bit, but the quality is more stable, and it can rotate approximate 200 degrees. Okay, the information estimate with the blue servo, and the information right here is just approximate, and it's just a theory. Okay, and the last one is MG996R. This is the most expensive in 3 types, but the quality is good, and it can be pulled stronger. When you supply 4.8 voltage, it can be pulled 8 kg, and with 6 voltage, it can be pulled 10 kg, and the angle also 180 degrees. There's some type of servo 360 degrees. Okay, but I just use 180 degrees to make an example for you. And in this video, I will use the black servo to make an example. First of all, before we use PWM to control the servo, I will create a PWM signal by set high or low level the digital signal from the Arduino with the function that is delayMicroseconds, and this is the time parameters. We will transfer the time parameter to right here. Okay, this is how servo work. We use period is 20 milliseconds. If you want your servo is rotate to 0 degrees, that is called minimum pulse. You have to make an output as the digital pins is high in 1 millisecond, and then off. It means make an output low voltage in the 90 millisecond left. And when you want your servo is at the mid is 90 degree, you have to make an output as the digital pin at 1.5 millisecond. And the other, when you change to 180 degrees, you have to make an output is 2 millisecond at high voltage, okay? And low voltage is 80 millisecond. Okay, that's how control the servo by digital signal. Okay, now let's check the diagram. I have a diagram right here. The servo has 3 pins. The orange is the signal. I will connect to the pin 9. You can connect to the other digital pin, okay, but I will connect to the pin 9 for the PWM function after that. And the mid is the red. The red is connect to 5 voltage, and the last one is ground. Okay, let's pick the circuit. I have a black servo right here, and it also have 3 pins, orange, red, and GND is corresponding with the signal VCC and GND, okay? And I have also used 3 wire as the diagram, that is red, green, and black. Okay, now we'll connect to my servo. With red is VCC, green is signal, and the last one is GND. Okay, now connect to the Arduino. Signal to pin 9. VCC 5 voltage. And the last one is GND. Okay. Okay, before we control, I have some code right here. This is the code to control the servo by digital signal. I use pin 9, so I will make the pin 9 as an output. Next, in the void loop function, make a high level at pin 9 and then delay 1 millisecond. But right here I will use microsecond, so I will use 1000 right here. And then I will make an output low voltage, but right here I have to change it to 19,000 because my period is 20 millisecond. Here 20 millisecond, and if I make an output with high voltage in 1 millisecond, I have to make an output for low voltage in 19 seconds. Okay, and right here 19 seconds. Okay, now let's check. Okay, it's quite approximate with 0 degree right, but right here is quite noise and approximate with 0 degree, so it can run to here. Okay. Oh, there's something wrong with my servo. And when I supply is with 0 volt, 0 degree, I can move it. It's quite hard to move. Okay, now I have to change it to 1500. Here is 1A5. Okay, let's check. It will rotate to the mid center. Okay, as you see, it will move to the center. That's a 0 degree. And the last one, I will change to 2000. And here is A0. Okay, let's check. It will turn to the left. Okay, you see? It changed to the left. Okay. Okay, now we have to control it via PWM, and before that we have to know what the analog pins. The PWM pins is the pins had a tilde before it. Example 11, 10, 9, 6, 5, and 3. Okay? Just this pin can use PWM to control the servo. And to control the servo, I have a servo library in IDE. We have the servo library inside the IDE Arduino. You have to move to File Section, Example, Servo Section, and select to Sweep Project. Okay, let's check. I have to move to Example, Servo, and Sweep. Okay, this is the sample code. So now I will use the node diagram. Okay, the node diagram is also assembled with the old diagram. I also connect it to the pin 9. Okay, let's check. See what happened when I upload the sweep project to the Arduino. Okay, my Arduino is rotate from the left to right and then from the right to left. With my servo, on the right is 0 degrees and on the left is 180 degrees. Okay, remember that. Just my servo. And here, this is some code. The code right here is rotate from the 0 degree to 180 degree. And then it's rotate from the 880 degree to the 0 degree. Okay, that means it's run from the left to right and right to left. Okay, it's easy, right? Now I have another sample. That's it. I'll use the potentiometer to control the servo. Sample when I turn the potentiometer to left or right, the servo will rotate like the potentiometer. Okay, let's check the diagram. This is the diagram. The diagram is I will connect to Arduino to servo, and the left pin of potentiometer is 5 voltage, and the GND of servo with the right pin of potentiometer to GND, and the center pin of potentiometer will connect to A0 to read analog, and the signal of servo I will connect to pin 9. Okay, let's connect the circuit. Okay, let's check my circuit. Right here I have 3 pins of servo is connected to 3 wires. Okay, but 5 voltage I have to connect to the test board because I just have one 5 voltage on Arduino. Okay, and with potentiometer I will use the 1 kilo ohms. Okay, you can use the other value, but right here I will use 1 kilo ohm. Okay, we'll connect to test board. Okay, ground of servo I will connect to ground of Arduino, and this is the signal of servo I will connect to pin 9. Okay, now I will use the yellow wire to connect 5 voltage to the potentiometer. That is the left pins. Okay, I will connect to 5 voltage here. Okay, now use the orange as the diagram to connect to A0. That is analog pins. Okay, I will connect to A0. And the last one is ground. I will connect to the right pin of potentiometer to ground of Arduino. Okay, and the last one 5 voltage to 5 voltage here. Okay, you can see it. Okay, now I will code some code for you. First of all, I have to check the analog read from the potentiometer. Okay, comment it, delete it. I'll use the serial monitor to print out the value of potentiometer. Okay, serial.begin at 9600 baud rate. Okay, right here I will print out the value from analog at pin A0. Okay, I will connect my Arduino to laptop and check what happened. This is the old code, but don't worry about that. Okay, let's check. So the serial monitor is opened. Okay, this is the value of potentiometer. Now we'll turn to left. Turn to left, the variable is increase, and max is about 940. Okay, the max is 940, and the min is 0. Okay, let's check max again. Okay, max is 940. It's approximate with 1030. Okay, now I have to convert that variable to the decrease we want to control. Okay, I have max is 940 and the decrease of us is 180. Max, min is 0, right? And the variable min is 0. Okay, now we take the 940 divided by 180. Okay, 940 divide 180. That about 5. Okay, we will take the integer 5. Okay, now use 5 to multiply the variable to get the control signal. I'll use the sweep. Okay, right here I will delete. Okay, remember this function is control the servo. Okay, now I will have a int variable right here. I will put the name is read analog is from analog pins A0. Okay, and then convert. I have a variable convert. Okay, convert is read analog divide by 5. Okay, divide by 5, and then I will transfer the convert here. Okay, now let's check. Upload. Let's check my servo. My servo is rotate to left, right. Now I will turn the potentiometer to right. Okay, let's see. Right. Okay, and then try again. I will turn to the left. Okay, let's see how I control the servo from the potentiometer. You can use this way to control with the other analog device. You can read the analog signal from the other device and then control the servo to do what you want. Okay, thank you for watching the video.